Well, good evening, everyone, and welcome to the second talk in Rice University's Planet Now webinar series featuring current conversations in environmental studies. My name is Richard Johnson. I'm the Sustainability Director at Rice University. I also co-direct the Environmental Studies program, which is overseen by Rice's Center for Environmental Studies. The Director of the Center for Environmental Studies is Dr. Joseph Campagna, and I want to thank him for his leadership and partnership in this series. Student interest in environmental programs at Rice is surging, and Joe has done a remarkable job in overseeing the expansion of the program to meet the rising level of student demand and in creating opportunities, in particular for our graduate student community. We are particularly grateful to the Humanities Research Center at Rice for helping to provide resources to make many of these opportunities possible, including through their Diluvial Houston grant from the Mellon Foundation. We have a wonderful staff who have assisted in making tonight's program possible. And I want to be sure to recognize and to thank Andrew Steffel, John Waterhouse, Tara Ousley, and Dr. Sean Smith. And Andrew and John are running mission control right now for us in this event. Our center and program are interdisciplinary in nature, and that is reflected in our joint home in the Schools of Architecture and Humanities at Rice. Thank you to Deans John Kasparian and Kathleen Canning for your ongoing and unwaveringly enthusiastic support. Tonight, I am joined by a co-moderator, Professor Reeves Taylor. Reeves is a lecturer in Rice's School of Architecture and an adjunct associate professor at the University of Houston, which somehow he manages to do while also serving as the firm-wide design resilience co-leader and principal for the international design firm Gensler. I've known Reeves for several decades now, have worked closely with his classes for 15 years, look forward to partnering with him and his classes going forward. Many of his students are tuned in tonight. I'm pleased to welcome Reeves as well as his class, and he will be joining for tonight's Q&A session. This fall, our focus for the Planet Now series is primarily on the intersection of climate and justice. As we've recently passed the official end of summer, it's worth noting that the Northern Hemisphere just had its hottest summer on record. The record was previously held by the year 2019, but of course 2020 is all like, hey, I'm gonna one up you, right? So here in the Houston area, we set our own record, though it didn't get much attention. The record was set for the warmest overnight low temperature ever recorded, and that happened a little over a month ago. The overnight low for temperature in Houston that evening was a sweltering 83 degrees, and down on Galveston, it was 87 degrees. Weather events like this and how they are exacerbated by our built environment and the impacts they have on people is the expertise of tonight's guest speaker. Dr. Ladd Keith is on the faculty of the College of Architecture, Planning, and Landscape Architecture, otherwise known as CAPLA, at the University of Arizona. He is an assistant professor of planning and sustainable built environments, and he chairs their Sustainable Built Environment program, which I'd like to get him to talk more about later in the webinar. The University of Arizona has an extraordinary university-wide initiative focused on teaching, research, and service for the built environment called Restruct, and CAPLA is a leading voice in that effort. Dr. Keith's transdisciplinary approach fits this ambitious initiative perfectly. He served a full 8-year term on the City of Tucson's Planning Commission and was chaired during the creation and adoption of their General and Sustainability Plan. He is an active member of the Urban Land Institute and was recognized as one of ULI's 40 under 40. And hot off the presses, he was recently appointed to Tucson Mayor Regina Romero's Climate Action Advisory Council to create and implement that city's first climate action and adaptation plan. So congratulations, Ladd, on that honor. So Ladd, I want to say personally how honored we are to have someone with your level of expertise here to join us on this important issue tonight. The topic of urban heat pulls together so many immediate threads, including our changing climate, our relationships with and responsibilities to one another, our health, how we build, and how we live. So for our audience, we'll have plenty of time after Ladd's presentation for questions. So the presentation will be about 35 minutes. And then I encourage you to type questions at any time in the Q&A function of the Zoom platform. So at this time, I want to yield the virtual floor to our guest tonight, Ladd Keith. And Ladd, you can begin the presentation when you are ready.
Great, thank you so much, Richard, for having me. Let me pull up the presentation here. Yep, so thank you so much, Richard. Thank you for the introduction and having me virtually with the Rice University students and broader community. Again, my name is Ladd Keith and I'm at the University of Arizona, and I broadly study the intersection between urban planning and climate change, but as Richard mentioned, one of those issues that's come to the forefront is really looking at extreme heat and how cities are planning for that risk. So urban heat is an increasing climate risk. When you think about extreme heat, which is temperatures that are hotter or more humid than average, and that varies by different geographies and city types, we're going to continue to see increases in intensity, duration, and frequency of that extreme heat. And this is just an image from one of the heat waves we've had this summer in the Southwest. This one was pulled from September 6th, but it's already going into early October, and we're facing another one right now. So I'll kind of cover some of the contributors to extreme heat, discuss two research projects that I've been working with on colleagues on extreme heat and how that intersects with inequity. So three of the contributors when we want to think about extreme heat, one is just natural weather variability. The other, of course, is climate change, which is the increase of average temperatures. And then, of course, the urban heat island effect, and I'll go into those in a little bit more detail. But one thing to keep in mind is that extreme heat is both an acute and a chronic risk. And so particularly thinking about the equity aspect of this, an acute extreme heat event would be something like an extreme heat wave that's potentially like in the news and people are talking about. But heat is also a chronic risk. And so outside of those heat waves that get those media attention and press, we want to think about those families and those populations that are kind of in continually hot circumstances that are unsafe. So one of the contributors to urban heat, of course, is climate change. And as I mentioned before, that's the increase in average temperatures. And as you can see in the graphic here, just a slight increase in that average global temperature can lead on the tail of the right-hand side to much more hot weather and much more extreme hot weather. And so those small average increases can actually push us into new climate thresholds. And particularly for cities that may have been built in certain ways, and the population may be used to certain things that pushes them into new thresholds that they're not used to dealing with. And so the fastest warming cities in the United States, famously the Southwest is unfortunately home to the top four, but Las Vegas, El Paso, Tucson, and Phoenix. 19 is Houston, but I would say that doesn't mean that Houston is escaping this. No city is, whether they're temperate or hot and humid, or maybe in the desert, arid Southwest. But Houston's temperature has increased on average 3.58 degrees Fahrenheit since 1970. And I just pulled this from the US Climate Explorer, but by the year 2100, which is under the high emission scenario, with greenhouse gas emissions that we're unfortunately kind of barreling towards right now, we're looking at Houston projected to have about 60 additional days above 100 degrees Fahrenheit. And so that's quite a few more days, especially with Houston's humidity, looking at how that'll change kind of the makeup of the built environment and how people have to adapt to that. So of course, one of the big contributors to urban heat is the urban heat island effect. And that's kind of entered more of the mainstream lexicon, especially the last couple of years. And so you hear this reported about and people talking about it more in, in normal conversation. But it's the idea that the way that we build and design and plan our built environment, and the way that we operate machinery and all of those human kind of contributors exacerbates the heat in urban areas compared to their rural counterparts. And so those are due to things like land use and cover change. So the fact that we're taking out vegetation and natural open spaces, the urban form and how that form is arranged with density and height, the type of buildings that we use and the amount of reflectivity they have, or if they hold that heat during the day. The amount of vegetation and humidity that we'll get into more later. And then of course, like I mentioned, waste heat emissions. And so whether it's air conditioning or automobiles or other mechanical uses, all those things contribute to that. The thing I like about this graphic is the orange shows the daytime temperatures and the blue shows the nighttime temperatures. And you can see that, on average, the denser areas are usually a little bit hotter, and certainly in the more rural or suburban areas, the temperature may become a little bit cooler. The one thing, it's always a complex thing to talk about though, because as you can see, the pond is kind of an outlier. And so research has shown in places like Phoenix, if you have a swimming pool in your backyard, that may actually cool it down during the day, but then it also raises the temperature at night. And so we see that kind of relationship with natural bodies of water too. So it's not as simple as kind of the hottest areas in the center and everything else is cool. And certainly one other thing to point out here is that while the downtown in this kind of fake schematic is one of the hotter areas, you can certainly see that the warehouse or industrial spaces with kind of their large roofs and parking lots is also one of the hotter. And so that's something that we see kind of bear out in cities across the United States as well. So another thing to think about with the urban heat island effect, just on average, the temperature differential can be 10 degrees Fahrenheit, but it can be as drastic as 22 degrees Fahrenheit on the hottest days. And so, 10 degrees is quite a bit, but 22 degrees, you're looking at some major implications from that. And I would point out that there's many different ways of understanding the urban heat through urban heat island mapping too. And so urban heat island maps like this one that's shown is one way to do it. And that shows with satellite data that's showing the amount of reflectivity and temperature differentials. But we also want to make sure that we're looking at social vulnerability indexes, SVI, or vulnerability maps. There's also vegetation maps that are used, and then increasingly people are looking at ambient air temperature maps. And I believe Houston is actually going through a campaign this summer doing an ambient air temperature mapping exercise. And then of course, looking at those future climate change projections too to understand. So one thing I like to point out with this map, this is actually the city of Tucson's current urban heat island map. And you can see the yellow circle is our downtown area. And one of the misconceptions about urban heat islands is that the denser downtown areas with the higher populations are always the hotter areas of the city. And you can see here that it's actually, on average, there's some hot spaces, but it's actually one of the cooler places too. And that's because if you use vegetation appropriately and design that density correctly, it doesn't necessarily have to be the hottest area. The blue circle kind of in the middle, the blue oval, is actually the University of Arizona campus, which I would say is another one of those denser spaces in the city of Tucson. And you can see it actually comes out here as being one of the cooler areas, again, because it's using a lot of that vegetation. And then kind of on the right-hand side of the map is the red circle is, of course, one of the malls in the Tucson area. Malls with their parking lots tend to be some of the worst. And then you can see, obviously, a park in the blue, which they usually come up as cooler spaces. But the other big thing to notice here, and you wouldn't know this if you're not from Tucson, but the further south you go is the lower income, marginalized, kind of higher minority population area, so South Tucson. And as you go further north, that's what we call Midtown. And so that's a trend that we see through cities too. And certainly those lower income areas tend to be hotter for lots of different reasons. So there are a number of impacts from urban heat. The number one is public health. And of course, it's well documented and talked about more oftenly now, but extreme heat is actually the number one weather-related killer in the United States, above hurricanes, tornadoes, all other weather-related disasters. But kind of thinking more broadly than just that, of course, we want to think about the quality of life. And if you live in a hot space like many of you in Houston do too, or myself in Tucson, it's questions about whether you can take your kids to the park during the middle of the day, whether those parks are adequately shaded, can you go shopping, can you carry on those kind of quality of life daytime activities. Heat also has a big economic impact, and studies have shown that during extreme heat events and heat waves, it actually depresses economic activity quite a bit. And of course, we see rising energy and water use during those heat events as well. And so there's a nexus between heat and energy and water that we want to think through. Of course, there's well-documented kind of dramatic infrastructure questions with urban heat. And so I'm thinking of in Phoenix to my north, during an extreme heat event or a heat wave, they'll sometimes have to shut down the runways because their airplanes aren't designed to take off at above certain temperatures. But kind of beyond that, we make major roadway investments, and cities are installing things like light rail. So are those stops and those major infrastructure investments being designed with urban heat in mind? Of course, landscapes is another big question. And One is, are the landscapes that we're planting currently going to thrive in the climate of the future, not just the climate that we've experienced in the past? But there's also been well-documented cases where urban ecology tends to be much more depressed and suffers in those higher heat areas as well. And then finally, many of our current planning ideals, and I would say many of the current kind of city ideals of increasing density, increasing walkability, are all threatened by rising temperatures, because it's going to be harder to get people out of their cars and using alternative modes of transportation if the temperatures keep rising. So kind of specifically on the question of urban heat and equity, so just some considerations before I get into two of the projects I've been working on. One is that there's a very complex interplay between existing inequities in cities and climate change and the urban heat island effect. So of course, thinking about the older school environmental justice kind of questions, where the lower income populations and those marginalized populations and where in the cities have higher temperatures, and those are usually very closely associated. And then of course, a newer topic, but climate justice, is those that have benefited the most from the carbon economy and those who have made the most money from it are typically the ones that are best able to adapt to higher temperatures through air conditioning or moving to different climates. And those who have benefited the least from the carbon economy are those that are suffering the most. And so you can think of that kind of on a global scale, or certainly within our own cities too. And so again, research is just very well documented that increased heat health risks are most prevalent for vulnerable populations. And so again, those are often marginalized communities and the lower income areas. And this year, there's been 2 papers that have made national press by some of my colleagues. And so those are looking at the legacy of redlining in extreme heat. And so one of those papers, which was by Jeremy Hoffman, showed, and that's what the graphic is of here, shows that basically those redline neighborhoods, which were kind of systematically discriminated against and were, to this day, even after the practice was made illegal, to this day are still much hotter on average than those neighborhoods rated highest, which were not redlined. And so you can see pretty dramatically with the blue, those not redlined neighborhoods compared with the red, in Portland, Oregon being one of the examples. And some of those temperature differences can be up to 6 degrees. So that's quite a dramatic difference for those past inequities and how they're still kind of carrying forward in the built environment today. So kind of with that as background, one of the things that a colleague of mine and I wanted to look into, and she's Sarah Miro, she's a fantastic researcher up at Arizona State University. We wanted to look into what research was actually saying about extreme heat, because we hadn't seen any papers out there about kind of documenting the current research of planning for extreme heat. And so kind of some background to that is a recent American Planning Association survey showed 70% of planners were worried about extreme heat, and they ranked heat 4th out of 14 hazards that are experienced in different cities. But an assessment of 3,500 online climate adaptation resources found that only 4% of those focused on heat. So there's a huge disconnect between, again, those impacts that I was discussing earlier, the concern that planners currently have about extreme heat, and the actual resources that are available to them to deal with it. So 2 questions that we were asking with this literature review was, what's the current state of research on planning for extreme heat? And what are those gaps in knowledge that need to be addressed to advance extreme heat planning? And so we did a systematic literature review and basically narrowed down papers after research for extreme heat planning or urban heat in the title, abstract, or keywords, and resulted in 589 articles. And we narrowed those down to those that are specifically looking at planning processes, which resulted in the 21 papers that I'll discuss. One thing out of the 589 papers that came out in our total sample that's pretty striking here is that extreme heat research is absolutely on the rise. And so 60% of those papers were written within the last 5 years. And so kind of thinking back to that lack of practitioner resources, it's not surprising if research is just now starting to look at extreme heat that the kind of equivalent practitioner resources aren't available yet. But that's pretty striking that it's so prevalent now, but it's just recently come to the forefront. Another thing that's pretty striking was out of those 589 papers we looked at, the majority, about 70% of them were focused on mapping and modeling extreme heat, but much less were focused on designing for extreme heat, or again, 7% focusing on those planning processes that we were really interested in. So modeling and mapping extreme heat, very important, but we have to move past that, and to actually make changes, we have to understand how to make those changes in the built environment and kind of our government structures too. And then just briefly, the geographic focus of these publications. So we took a worldwide sample, although of course they were English papers, so we may have missed some of those non-English papers that have been published, but not surprising that the majority of papers are from China or the United States, just because those are two of the major producers of all types of publications in the world. I think it is notable here that Australia was number 3, which you don't see very often, but Australia does some fantastic urban heat island research as well, just because it's such a topic of importance there too. I would say the only other thing important to note here is that many countries aren't listed, and many geographies in the global south are not represented very well in this spread. So there's certainly concern that some countries aren't getting adequate representation in the research that's being produced. So some themes that we saw reading through those, again, those papers focused explicitly on planning processes. One was looking at institutional challenges and opportunities. And so a lot of the papers, even within that small subsection of planning processes, were still very kind of focused on climatology or public health or planning. And that's something that I've certainly seen in practice too. So the idea that we need to break down those disciplinary silos that currently exist. Another major topic was mainstreaming extreme heat into existing plans and processes, and kind of the difficulty in doing that compared to things like flood risk. There was also a lot of discussion about the need for appropriate scales of action and information and strategies. And again, I showed you that urban heat island map for Tucson that was kind of at the city level, but we need to connect what we know at that city level to what actually works at the site-specific level, and kind of understanding those benefits better. Then legal structures needed for extreme heat planning. And the interesting thing was this was across the world again. It wasn't United States specific, but just compared to other climate risk, there's not a lot of existing legal structures for extreme heat planning in the same way that cities across the world plan for things like flooding or wildfires. And then of course, acknowledging complexities, different priorities, and limited resources, which is absolutely not specific to extreme heat, but that's something that any kind of environmental or sustainability or resilience planning is going to be dealing with. We found 2 major buckets of kind of how cities are thinking of planning for extreme heat and addressing them. One was under risk management activities, and under this category would be things like emergency management, cooling centers, things that are more focused on those extreme heat events like I mentioned earlier. But I think it's important to note here that the focus is on managing heat only as an emergency issue and not addressing it as a truly chronic risk, which if it was addressed as a chronic risk, you would hope would have more equity implications. And so kind of what we found was that there's a need to understand and address the root causes of vulnerability in order to advance equity versus just focusing on those flashy extreme heat events that the newspapers write about. And then we also had a bucket of designing for the built environment to address extreme heat. And notable that many of those design strategies are very location specific, and they often focus solely on technical and material solutions. So I'll talk about that in the next few slides. One major bucket, of course, is vegetation. And so a lot of cities are looking at how they can increase their vegetation through urban forestry, green infrastructure, green roofs and walls, and parks and open space to help address extreme heat. Notable that especially green roofs and walls was one of those that's very location specific. And so green roofs and walls don't work very well in a desert Southwest type environment, but might be more appropriate for temperate climates like in the Northwest or the Midwest or the Northeast. Another big area was buildings and urban infrastructure. And so again, that, just like the urban heat islands map that I showed earlier, involves the orientation, shaping, and massing, updating building standards for new buildings that are coming online, but also weatherization of existing buildings was a big topic. And so you can imagine those existing buildings, particularly the lower income houses or apartments, need to be upgraded in order to make that air conditioning work or keep those residents safe. And then, of course, the adoption of air conditioning was talked about in quite a lot of those papers as well. Another major one, kind of at the larger city or regional scale, was land use and urban form changes. And so this is a graphic from Jeffrey Raven, who's done some work with ULI and is kind of notable for his work on urban climatology. But looking at the urban geometry and density, things like large-scale ventilation corridors, thinking about the location and size of parks and open space throughout the city. And then also, like I mentioned, water features can have both a cooling effect and a heating effect. And then, interestingly, also the idea of tying heat and land conservation. So the idea that we shouldn't develop those natural areas or those farmlands because they're actually currently providing a cooling effect for cities, and kind of recognizing them for that benefit that they're providing. So one thing that we talked about in this paper as well was complexities, trade-offs, and maladaptation. And so a lot of the papers talked about how there's just so many complexities and how all of these different strategies interact with each other. And we don't really understand much beyond the specific strategy, how all of these strategies work as a suite. The scale of strategy, again, versus the scale of benefit was a big one. And so an example I'm remembering from one of the papers was, if you paint a high density apartment building, if you paint the roof a reflective white color, it could have the impact of reducing the heat of the building, but it's not going to benefit those pedestrians on the street walking by that building. And so again, it's just the difference between the strategy and the scale of benefit, and not, as practitioners and researchers, not mixing those things up and putting them all together. Weighing the trade-offs between heat mitigation and other goals. And so I have a picture here. The left-hand picture is of green infrastructure in the city of Tucson. And obviously, if we do this well, we can hopefully capture natural rainwater, which can help increase vegetation, which decreases the urban heat island effect. But, you know, it doesn't rain here all the time. And this summer has actually been one of the worst summers for rainfall in our history since we've recorded rainfall. And so the idea that even with green infrastructure and these kind of cutting edge techniques in landscape design, a lot of trees and vegetation in the Southwest are still going to require some amount of irrigation, and thinking about our water conservation goals and how those things balanced off. And then the danger of maladaptation in heat mitigation strategies. And so the other image is of air conditioning on an older building. And so there's a lot of consternation in cities like New York City about adopting air conditioning, which they're kind of passing that threshold where they need to have air conditioning and central air installed in those buildings that don't yet have them. But that moves them further away from their greenhouse gas emissions reduction goals. And so the idea, again, that if we're going to do those air conditioners because they absolutely have an equity component, and we need to do that, we also have to budget in weatherization of those buildings to make sure that we're not spending more energy than we need to. And then finally, energy efficiency goals may have unrecognized heat reduction goals. And so that's another one, kind of like land conservation, where we're already doing a lot to make buildings more sustainable and reduce energy loads. But those same efforts may actually reduce waste heat, which contributes to the urban heat island effect. And that's something we're already doing, but we're not really vocalizing and talking about it. So that might be a bright spot of something that we could kind of put into the bucket of why we should do energy efficiency in buildings. Information uses and areas of needs was something a lot of the papers talked about. And so again, we need to focus more on the appropriate use of those urban heat island maps and models. And we found in the literature that there was a limited use of climate change projections. And so a lot of them are referring to urban heat island maps and models, but they're not looking at what their cities are projected to turn into by 2050 or 2100. There's a lack of information in the planning realm on heat health risks and vulnerabilities. I would say there's absolutely not a lack of information in the public health realm, but we're not doing a good job of bridging those two disciplines. And then again, we really need to quantify the costs and benefit of those heat mitigation strategies, particularly if we're going to ask cities to make millions of dollars of investment in things like urban forestry and other strategies. The research being produced is not always useful for decision making. Again, this is not specific to urban heat, but is particularly a problem with urban heat because, again, if only 4% of those adaptation resources that I mentioned earlier address urban heat, it's not surprising that decision makers lack training for extreme heat planning. And so we really need to be producing research that's much more useful for decision makers and kind of aimed at how to get it into their hands as fast as possible. So just a couple of future research directions, and then I'll share a survey that we've done on urban planners on extreme heat. But future research directions from this particular paper, again, research being produced has largely focused on modeling versus the planning processes. So we think the planning processes and design is a big area of opportunity. There needs to be an increase of usability for extreme heat research. And of course, decision makers, since they lack the training to use the information, we should really focus on training those practitioners as best we can, whether that's universities or through other methods of how to use that information. And then the idea of mainstreaming extreme heat into relevant departments and processes. And then, like I mentioned before, there's a focus on technical solutions for the built environment rather than addressing those social inequities. And again, cities are looking at things like urban forestry versus increasing the quality of affordable housing. And if you have affordable housing where residents can safely kind of stay indoors during an extreme heat wave, that's a very different thing than looking at planting a couple of trees in front of their houses. So we kind of need to look at both of those sides of the equation. So the second project I'll share with everyone is a survey that Sarah Miro and I again completed on US planners for extreme heat. And we asked a couple of different questions through the survey, and we sent it out last year. And so we were really interested, kind of now that we have this literature review, how are planners perceiving extreme heat risk in real life? How are different cities and sectors impacted? What are their actual information sources and needs? And what planning and design strategies are those communities really using? And then what are the barriers that the planners report in advancing heat planning? And so we did 2 surveys of planners across the United States. One was a targeted sample. And so with this one, we randomly selected 111 cities across the different national climate assessment regions, which are in the colorized map on the left. And we made sure that we picked large, medium, and small cities because we weren't just interested in those kind of progressive cities with a lot of resources that have a university attached to them, but we really wanted to see, you know, across all of the United States, what are the smaller cities that don't have those same resources? What are they doing too? And then we did a convenient sample survey that we distributed through professional networks, and we had 98 planners complete that. And that one would be more kind of the planners that are very excited about all types of urban resilience planning and sustainability planning. So just, you know, a hypothesis here would be you would expect to see kind of higher action and higher interest in the convenient sample than the targeted sample. So we asked, what are those planners' heat risk perceptions? And again, in your role as a planner, how concerned are you about extreme heat in the communities that you work with? And then the following 2 contributors to extreme heat in the communities you work with. And so on the left-hand side, you can see, again, that targeted sample that's kind of a truer representation of cities in the United States. And then that more excited sample, which would be the general sample in the pink color. And you can see that planners kind of across the board are reporting impacts across economic, environmental, and health. And of course, like we suspected, the general sample was a little bit higher than that more true national sample. But interestingly, climate change and urban heat island were both pretty equally marked as a concern by those planners as contributors to extreme heat. We asked those planners, to the best of their knowledge, what has been impacted in the last 5 years due to extreme heat in the communities. And you can see it's kind of organized so that the more reported impacts are on the left-hand side. So energy and water use are the top 2, which is kind of interesting. And then urban vegetation and wildlife is the third, which we found interesting, particularly because more of the research focuses again on that public health kind of aspect and those impacts to extreme heat. But I think it's really interesting that in both public health and quality of life, the 2 samples really diverge. And again, that more excited kind of more choir resilience planning group is much more concerned about those public health and quality of life type issues, which I would say are very closely connected to equity, more so than the kind of truer sample of cities across the United States. And then kind of interesting, if you go down labor, productivity, economic development, and retail, we're kind of on the lower end for everyone as far as what they are concerned about with heat. As far as where planners are addressing extreme heat, we asked them which plans actually, have extreme heat addressed in them. And of course, this is what the planners are reporting, but you can see on the left-hand side, sustainability, climate plans, resilience plans was one of the top reported responses. And again, not surprising that the general sample had more, more people reporting that they were putting them into there. But I think it's important to note too that planners are also aware of emergency response plans, comprehensive plans, hazard mitigation plans, kind of across the board. And so the fact that there's not a lot of resources out there for them to plan for it, but that 25% roughly are trying to address it in these different plans is an important thing. Then we asked them what strategies are they implementing, and not surprising to me because a lot of their literature kind of reflects this, but urban forestry was the top one. So urban forestry is a very popular technique. Emergency response was the second one. And then kind of looking down weatherization of those existing buildings was the third. But if you kind of go over again, you can see that it starts to diverge with those more, planners focused on resilience, and that the choir of heat planners, I would say, is much more interested in things like utility assistance, information awareness, cooling centers, and vulnerable populations. And so there may be a divergence between, again, those smaller cities that have less resources and less information available, and those larger cities that may have more access to universities and things like that. So, and we're still looking into kind of some of the causes of these differences, but I think that's an important thing to just kind of look at. Then we looked at information gaps, and this is just displaying the percent that said they do not use them because the information is not available. So again, future climate change scenarios is not being used because they're not available for a majority of the cities in both camps. And those urban heat island maps, which are here categorized as land surface temperature maps, for the targeted sample that I would say reflects the truer kind of United States cities, not available to almost 75% of cities that responded. So, but again, kind of not surprising that those excited about it are reporting higher use of it. And you can kind of see heat vulnerability maps, again, over 50% of the targeted sample cities don't use them because they're not available, which has some really important equity implications too. So just a summary of those results, and again, we're still sorting through them, but 80% of planners reported that their communities were impacted by extreme heat. And again, this is across the whole United States, across cities of all sizes. The majority of planners in both camps reported that they were addressing heat in some way. And urban forestry, of course, was seen as the most often implemented plan, most often implemented strategy, and was also seen as the most effective strategy. We asked that question too. Dedicated staff was seen as effective, but not implemented, and the lack of staff was seen as a really important barrier. And so kind of, if you ask folks comparing heat with urban flood risk, usually cities have someone like a floodplain manager or a whole department of floodplain managers that are devoted to dealing with flood risk, but there's not a heat risk manager or a heat risk department in the same sort of way. And then other top barriers, again, this is across any kind of sustainability or resilience planning, but lack of resources and competing priorities were mentioned as important barriers to move things forward too. So kind of thinking through just advancing equitable urban heat resilience, some challenges and opportunities from both of those studies and additional things that I've been working on. Research is increasingly and rapidly looking at extreme heat as a climate risk. Urban heat health impacts on vulnerable populations are increasingly documented and recognized. And I would say last year particularly, a couple of really high profile reports came out, some Red Cross, the Union of Concerned Scientists, and the Urban Land Institute. And based on a couple of those really high profile reports, we're seeing more discussion publicly about those vulnerable populations and the heat health nexus with urban heat. But I would say a challenge is lack of national and state support for addressing urban heat. I would say across the board with all climate risks, we have a lack of national and state support, but particularly for urban heat, we're really lacking kind of targeted assistance for local communities, but that action is occurring at the local level as our survey documented. And then again, we're really seeing an over-reliance on technical solutions for a risk that compounds a lot of complex social inequities. So again, looking at urban forestry as the solution for urban heat versus thinking through kind of affordable, safe housing where people can actually stay indoors, and thinking through their transportation modes, and are they able to take a bus or walk safely to work if they don't want to choose to use a car, and a lot of those things that planners think about with those complex interactions. Obviously, just planting trees will not solve all of those problems, so we need to kind of move away from the silver bullet aspect of this. And then lack of existing local governance structure for urban heat. I would say this is both a challenge and an opportunity. And so it's a challenge because there's nothing there that, there's no model that cities can look at and copy, but it's an opportunity because it doesn't necessarily have to be tied into the disciplinary ways that we've done planning for things like urban flood risk. And so I've seen a lot of cities experimenting with kind of cooperative groups of climatologists and public health experts and planners and landscape designers coming together to address heat. And so that might form some kind of new kind of model for urban heat versus other climate risks. So that's something that we're kind of looking at as it evolves. So some related ongoing work that I'm doing that may come up in the discussion. We're following up with a survey of US planners to explore how COVID-19 and the ongoing pandemic has impacted those extreme heat planning efforts. I'm currently conducting a NOAA-funded research to map extreme heat planning and governance in 5 cities across the United States, and you'll notice that Houston is one of those cities that we'll be looking at, so that's kind of exciting. And then I'm leading an Aspen Global Change Institute workshop called Advancing the Theory and Practice of Urban Heat Resilience. And that's closed to kind of experts and practitioners that we've selected. But we do have a public webinar on equity and urban heat on the evening of Monday, October 19th, followed by a student poster session. So if any of the students out there are interested, I'll provide a link in a little bit and would love to get your participation in that. So a couple of resources, because I know we might have a variety of folks listening in, and not just university researchers, but the paper that myself and Sarah Miro and my former graduate student Tess Wagner wrote is available at tinyurl.com/extreme heat planning, so that's open access. I would mention the Urban Land Institute Scorched report that I was a science reviewer for, was one of those kind of landmark reports that came out last year that really shifted the conversation. And I like this one because it's really written in a kind of general public and accessible way, and it covers a lot of different aspects of extreme heat. And then the UA Extreme Heat Network that I lead, and that's at heat.arizona.edu. And that's a good place to subscribe to our list, or if you're interested in that student poster session, to keep an eye on, and we'll post that information when it's available. So I'd like to acknowledge, of course, Sarah Miro, who I couldn't have done this research without. Again, Tess Wagner, Erica Lynn Schmidt, who's my current GRA, and then we have a group of students from ASU working on this too, Autumn Miller and Kendra Elner, and then of course all of our community partners who continually put up with us sending out surveys and asking questions about extreme heat. So with that, hopefully we have enough time for questions and answers, but Richard, I'll turn it back over to you.
Well, thank you so much, Lad. I really appreciate that fine presentation. And maybe if you could stop sharing your screen,
Sure.
We can go into a conversational view. And if we can pull in Reeves Taylor, Reeves was also one of the contributors to that fine ULI report, Scorched, which I do highly recommend for those who are interested in the topic, because it includes a number of case studies of different solutions that were applied. And so I'd like to give Reeves the opportunity to ask a first question. Reeves, if you'd like to. And then I'll ask a question, but I want to encourage our viewers out there to put questions in the Q&A as well. We've got quite a few of them already. So Reeves, take it away.
Well, thank you, Lad. That was, amazing. I particularly like the fact, like us, you're trying to understand who's out there that's even getting their arms around that. What's interesting from my perspective, and it may be a slight different viewpoint, but most of those we're seeing in our practice of architecture planning at various scales that really are getting this are the individual landowners. You're right that the governance, the focus on in our part of the world, floods, et cetera, have tended to suck the air out of the room. But in that ULI article, or sorry, publication, which is very much looking at the public-private partnership that's necessary, we did uncover a lot of insights that property owners are gathering. In your research, did you get any sense that the planners were learning from the private realm versus from each other? Or more importantly, that they were engaging joint research with, say, large developers and others whose very existence through insurance or lease is very much dependent on this conversation?
Yeah, that's a great question. So in the survey, we asked public planners what they were working on specifically. So that's much more government focused, of course. And I would say what I saw in the literature review that we did was a bifurcation of those strategies that governments can control on publicly owned land, which I would suspect is leading to the over-reliance on urban forestry and kind of green infrastructure, because that's something that governments can kind of have control of and spend their money on across a whole city. And so certainly from the conversations I've had with the private sector and with even planners, there's an ongoing conversation that they know they're in an anti-regulation environment, and it's not just states like Arizona and Texas, but across the whole United States. And so I think that's one of the opportunities of the fact that we don't govern extreme heat like we do urban flood risk. And so a lot of the conversations I've had is kind of asking, how can we bring the private sector on board to make these changes, and without asking them with new regulations and new zoning requirements for heat. And so I think there's a lot of lessons learned from the kind of what we've done over the last 10 and 20 years about flood risk, that some of them are repeatable, and then a lot of other ones that are trying to look for new ways to do things.
Terrific. The only other observation I might make is in that interview with the builders and people who are building buildings. Of course, the whole agricultural issue is the heat is also impacting those who are trying to do work externally. So a lot of the mitigation you're talking about presupposes you have landscape staff or constructors or those working on the whole other challenge of food insecurity that we know climate and scorch is going to bring about. But literally working during the daytime will become a rarefied, if not endangered, reality. And I'm just curious in any of the thinking whether that shift to the night markets or the shift to daylight to nighttime reality was ever kind of present in that operational mindset with your planners.
Yeah, so we didn't ask specifically a question about that, but I would say if you look to Phoenix, to my north again, because they've kind of crossed those thresholds into unsafe working environments all year, for such a large part of the summer, they can't stop construction on roadways or other things. And so you're seeing absolutely kind of a cultural shift where they're adopting strategies to allow for safe work in the middle of the night and kind of having night shift people do construction and some of that outdoor work or roofing work because it's simply unsafe during the day for too much of the year now. And so you're even seeing things like I grew up in Arizona and we didn't used to have nighttime hikes before, but there's absolutely kind of a growing prevalence of kind of organized, before the pandemic, organized like outdoor exercise activities at night for hiking and stuff too. And I think you may see more of those things start to take shape.
So Lad, one of the something that pops out at me about dealing with urban heat is while you are confronting the complexity, of course, of climate change, you also have a lot of local variables where you can really have an impact and move the needle. And so I know that we have a lot of students tune in tonight who are looking for activist opportunities. What does urban heat activism look like, and what sorts of things can students do at the local level to influence, to support, to battle?
Yeah, I love that question, and I don't think I've heard the term urban heat activism coined yet. So you may be, at least for my hearing, you're the first one in a webinar setting, Richard, that's brought that up.
Well, we have it recorded here, so I get the footnote.
Nice. But yeah, I would say so. I'm kind of thinking of the city of Tucson as an example, the youth climate action movement and all of the marches that have gone on and the sustained activity. And they're particularly being led by kind of university undergraduates and graduate students. In the city of Tucson's case, moved the mayor forward to get the support to help do our climate action plan that's going to be in process soon. So I think, those activist movements, particularly like the youth climate movement that was really strong, are really important for that. I would say another opportunity is the more boring but equally important, things like cities have comprehensive and general plans that need to be updated, and in the state of Arizona, ours have to be updated every 10 years. They're not as exciting sometimes as a climate action plan, but they influence absolutely regulations and development codes. And so, when those things come up, or when hazard mitigation plans come up that most communities in the United States have to have to receive FEMA funding for mitigation activities, those are really good opportunities too, particularly because people who do public engagement for those plans are usually looking for youth to kind of participate and lend their voice. So both the exciting plans, and I would say, the less exciting plans that are exciting to planners like myself would be really important opportunities too.
So we have a number of questions, and one comes from a fantastic institution here in the state of Texas, UT Rio Grande Valley, and it comes from a faculty member in civil engineering. And he's asking about, what do you think about developing cooler types of concrete and asphalt, such as high reflectivity asphalt? Would cities be willing to pay more for those materials in order to lower the heat island effect?
Yeah, I mean, every city is different with their budgetary situation, but I would say that I've seen cities certainly experiment with those. And I think if you can, again, demonstrate the documented kind of cost benefit with it, I think cities would absolutely be interested in using those. And so I know Phoenix has tried a couple of those cooler pavements. I know famously Los Angeles tried reflective pavement, which some colleagues of mine at UCLA did some studies on. And if it's too reflective, it will actually reflect the heat back onto buildings, making, again, those building energy loads go up and increasing greenhouse gas emissions. And they actually increased the temperature experience for pedestrians by about 8 degrees as well. And so I'm all for cooler pavings. Reflective pavings and reflective coatings may be good for the tops of buildings, but we might have to be careful about them if they're kind of an environment where they can interact with people and other buildings and vegetation. But I think it's all about documenting the cost benefit. And like I mentioned in the research literature that we did, there's just not a lot of well-grounded cost benefit analysis for some of these strategies yet. So I think that's a major area that we need to improve on.
We had a question from a Rice student. So I guess it's sort of along the lines of, we say vegetation, but what exactly do we mean? Are they all created equal? She writes, has research been conducted on what types of vegetation or how much of it is necessary to improve urban heat issues? Of course, we live in very different landscapes. We deal with too much water. You deal with a complete absence of it for most of the year. So what works for you in terms of an acceptable planting doesn't work for us. So how would you answer that, Lad?
Yeah, that's a good question. And again, our literature review focused on the planning processes, and we didn't review all the design papers specifically, but I've read enough of them to know that one of our findings was, and this kind of goes to the same comment, that many of those solutions are so location specific. And so, researcher in city X looks at a certain type of landscape or kind of built environment typology, and then determines the outcomes and says, if you're in our city in this climate and you use this, this is the outcome you can expect. And of course, I think that's one of the challenges, right, Richard, is that doesn't transfer. Even between Phoenix and Tucson, we can't transfer a lot of those lessons because we have a different temperature, we have different rainfall amounts, we have different city sizes. And so I think that's one of the major challenges we're kind of looking at. So a lot of those location-specific design strategies we might not be able to recommend, but I think there's a lot of things that cities know that are applicable across the country. And I think again, Reeves is part of this too, but that Scorched report really tried to do a good job of picking those things that are kind of geography agnostic to, and you can kind of apply them to lots of different cities across the United States and the world. So.
We have a question here that's definitely not geography agnostic, and it's a really interesting one, I think. First, you're thanked for your insightful talk. So in areas of similar climate, are there any cultural considerations that would make some of the urban heat mitigation strategies challenging to implement? How can these cultural considerations be factored into heat planning adaptation? And this is probably something you're encountering in your work in Tucson.
Yeah, I love that question. So I would say the cultural differences between cities, and even within the same city, of what different cultures perceive as kind of beautiful or acceptable vegetation, has a lot to do with kind of what gets planted, what gets maintained. And so I would say that we need to do a much better job of that. And I certainly know that landscape architects understand that and are working on that. But two things that come to mind are, I did some work in El Paso, Texas, where the Tucson version of green infrastructure that's very natural and, desert plant life, but it looks like you could find it in the desert, was not acceptable to parts of the population in El Paso, Texas, that had a more traditional kind of landscape aesthetic, where clean yards and gravel and, particular, I would say like intentional plantings of bushes and flowers was kind of the valued aesthetic there. And so for that type of thing, it's really looking at the local culture and saying, how can we adjust this? How can we make this fit into what they think is beautiful as well, and not just implant ideas of what we think works in Tucson. I'd say another, one of my favorite stories is I led an Urban Land Institute panel for Miami, Florida, where we were looking at the waterfront resilience. And we did a lot of interviews with stakeholders while we were coming up with our panel recommendations. And one of the folks that we talked to was in charge of kind of tree planting efforts and urban forestry efforts. And she relayed a story where they were planting these trees in a Haitian neighborhood that had a lot of population that was recently immigrated. And this certain tree that they kept planting was continually kind of pulled out and thrown on the outskirts of the neighborhood. And so they finally went in and asked the neighborhood, like, why don't you like urban forestry, was their question. Why don't you like these efforts of urban forestry? We're trying to help you. And the neighbors said, this type of tree is viewed as kind of an evil spirit carrying tree in our culture. And by planting it in our neighborhood, you're attracting bad omens and bad luck, and it's viewed as a negative thing. And so, this group reassessed their efforts, asked the community what types of trees they liked, and found a tree that had the same environmental benefits, but not the cultural stigma. So I think just a perfect example that even well-intentioned, heat mitigation efforts can fail if you don't actually talk to the people that they're impacting.
So that's a fantastic answer to that question. We have one that's maybe near and dear to our hearts as Houstonians that came in. Going back to the notion that that we get rainfalls in one night that might be normal for you in a year. Can you describe the intersection between flood control and heat mitigation? How can the strategies be mutually beneficial?
Yeah, and I think that's a great question. I think it intersects with the most popular strategies that intersect for both of them, but kind of green infrastructure and urban forestry are often things that have co-benefits both for reducing flooding and decreasing the urban heat island effect. And so kind of thinking through those on both a site-specific level, but then also kind of equitably across the city and where are we actually planting those and who does it benefit. So I think a lot of cities are looking at those kind of as one and the same now, and kind of thinking through flood risk and urban heat at the same time. So, and I would say for the city of Tucson, our mayor and council recently passed a new utility fee that goes on top of kind of your water bill, your waste bill, and it's only for incomes above a certain level. So there's a lower income provision with it. And it is specifically for installing and maintaining green infrastructure. And it's actually the Tucson Water, so our water utility company, that's assessing that fee and kind of managing the green infrastructure. But I think, one of the things they talked about as a benefit when they implemented that was the urban heat reduction that would happen too.
So that is, would you call it a heat tax?
Mm-hmm.
I wouldn't call it a heat tax, certainly, but I'm not sure. I think a resilience fee, perhaps. But when they talked about the benefits, they certainly mentioned both flooding and heat at the same time. So,
Reeves, I'm thinking maybe we each ought to ask one more question, and then we'll wrap things up. I do want to encourage everyone. I've put this in the chat. We have a number of additional sessions of Planet Now coming up this fall. We'll be talking about more of those in a moment. Reeves, do you have a question you've been wanting to ask?
Well, actually, it's kind of in two questions, but for instance, in Houston, when we connect the flooding issues and the scorched or the heat issues, we have one very big topic, which is the amount of paving we have for our cars. Infamously in Houston, 1/3 of our territory is connected to parking spaces, driveways, etc. The mantra is for every human being in Houston, there's 25 to 27 parking spaces. So I wonder in the planning, back to what the public can do, is there some discussion, and I didn't see the question about, literally, whether it's the autonomous vehicle or the future of shared vehicles post-COVID, is anybody saying, one of the first things we should do is just eliminate the hard space for the car, or otherwise deal with it beyond, the concrete and asphalt technology that's material thinking. But how about that code around how much we set aside for cars, which has that dual impact of, in our part of the world, flooding and heat?
yeah, absolutely. And a different project that I didn't cover in today's talk, we gave cities urban heat island maps and then asked them how we could improve the maps, and then also ask them what they might use them for if we continue to provide support for them. And I would say several suburban communities around the Phoenix metropolitan area that we were working with were interested in documenting the effect that large parking lots have on the urban heat island effect, to go into the mayor and council and the city manager and say, hey, look, this is yet another reason why we should reduce the amount of parking that we're requiring. And it becomes like a quality of life, a public health, and then they can kind of document it and say there's a heat mitigation aspect to it too. So I think it kind of goes into the suite of reasons why you might be able to convince those decision makers to reduce parking. But yeah, that was actually a surprising thing, because that was the first thing that they started to talk about. So.
So as a nod to our connection with the School of Humanities, I want to bring a poet into this. There's a poet that I really like from Arizona named Alberto Rios, and he wrote of your home state that we are citizens of a place that is centuries and seconds old. So, Lad, your hometown of Tucson is arguably the longest continuously inhabited settlement in North America, which is remarkable given the extreme environment that you're in with respect to the heat and lack of water. But it's also, much like Houston, a city that has kind of flourished in the grand scheme of things in just the last instant of history. So given the urban heat discussion, what do you envision going forward for Tucson? And are there scenarios where certain areas of the city or certain areas of other American cities will become too hot during parts of the year to remain habitable? And if so, I mean, how will this influence human migration?
Yeah, that's a really good question. So I would say you're already starting to see cities pit themselves against each other in that way, with the migration question and kind of who's going to get the worst climate impacts. And so some Midwestern cities that are projected to have fare better with some of the climate impacts are saying, move here, because unlike Miami or Tucson or Phoenix, we're not going through these things, and we won't have extreme drought and heat and flooding and all of that. So I think you're already seeing cities kind of reorganize their thinking that way. But I would say that absolutely for the Southwest and Tucson and Phoenix, they're already taking these threats very seriously, and are doing things to the built environment. Like I mentioned, Tucson passing the infrastructure fee to do more green infrastructure and things like that. So I think unlivable is not going to be the case, but certainly as the climate impacts continue to increase, my question would be more, who is the city going to be more unlivable for? And it's never going to be the higher income or those that have a voice in the government. And it's always going to be those that are kind of marginalized populations, that have to, you know, just have to make do and don't have the income to either adjust their households or do other adaptations. And so it's really a question of livability for who. And so unfortunately, you know, we need to just keep focusing on those vulnerable populations and the equity aspect to make sure that any of those adaptations or resilience measures that we do really benefit the whole city, not just the few that are probably fine off already.
You know, I think that phrase, livable for whom, could probably be a talk in our spring series of Planet Now. I love that question. Before everyone leaves, I want to encourage you to register for our next Planet Now session, which is entitled, What is Climate Justice Now? It's on Monday, October 12th at 6 p.m. And our guest will be Dr. Ayanna Elizabeth Johnson. She's the founder and CEO of Ocean Collective, founder of Urban Ocean Lab. She's a co-creator of the Blue New Deal, a roadmap for including ocean and climate policy. She's the co-host of the How to Save a Planet podcast. She's co-editor of the recent anthology, All We Can Save, featuring essays from women at the forefront of the climate movement. I want to thank Dr. Ladd Keith, our good friend, who is also at the forefront of the climate movement. Ladd, we're deeply appreciative of your time and your efforts and being able to join us while juggling your own crazy Zoom schedule and managing all the classes that you do. I promised to give you a moment to talk about the Sustainable Built Environment program that you oversee. Can you take a moment to do that for us?
Oh, sure. Well, thank you so much for having me, Richard, and it's great to see you, Reeves. Even though I couldn't be there in person, I'll visit you guys in person soon, I'm sure. But yeah, I lead a Sustainable Built Environments program here at the University of Arizona, and I founded it about 10 years ago, and the idea behind that was to create an undergraduate degree that kind of spanned architecture, planning, and landscape architecture, and really tackled some of these important sustainability and resilience questions. And so we have about over 100 students normally on main campus. We have an online program that's fully online that's been launched for about 4 years that has about another 100 students. And then we just launched a micro campus, a global campus in Peru that's been kicking off with a Bachelor of Architecture program. So yeah, thank you. It's a great program, and anybody that has any questions about what we're trying to do with it or kind of our successes, I'd be happy to answer those offline after this.
Well, that's wonderful. So, I mean, we hope that this proves to be just one of many moments of connection and collaboration with you. And of course, we look forward to hearing about your future work with the Tucson Climate Action and Adaptation Plan. So if folks want to be able to get in contact with you or to follow you, I believe you have a newsletter, an Urban Heat newsletter?
Yeah, so they can go to heat.arizona.edu. And again, that would be a great place if they're interested in that upcoming student poster session in October. And they can also feel free to find me on Twitter or email me. So
great. And just a final note before we leave, the School of Humanities is here at Rice is hosting a session at 4 p.m. on Thursday featuring national historian and scholar Douglas Brinkley, and he's going to be doing a post-mortem of the first presidential debate. And so that's going to be 4 p.m. Thursday. And if you go to humanities.rice.edu/2020-election, I better put that in the chat. Joe, can I get you to jump in and put that in the chat for me before I let everyone go? And then finally, I just want to say to our audience, thank you for tuning in to the Planet Now series. We appreciate that you chose to give us an hour, or it's sort of an hour and 6 minutes of your time. We hope that you've concluded that it was time well spent. We look forward to seeing you on October the 12th. And before we leave, I am going to put that URL in the chat. So I've got one last lightning question for you, Ladd, while I'm doing this. I once heard you say that if we started naming heat waves like we name hurricanes, that we would pay more attention to them. Do you want to respond to that really quick?
Oh, no, no, no. So I'm firmly in the opposite camp where I think, particularly because I see extreme heat and urban heat as more of a chronic problem, I'm more focused on how do we address those inequities like unsafe housing and things like that. And, let's not focus so much on those heat waves that get media press, particularly because if you look at places like the Southwest, we've been living in a heat wave this entire year. So where would it start and end?
Oh,
So.
well, thank you for straightening me out on that. Okay, everyone. So, Lad, once again, thank you so much. I want to thank Reeves Taylor for being my partner
Great pleasure.
in
Thank you.
moderating. So, from Rice University in Houston, good night, everyone.